Righto, so what I'm going to do first of all is I'll machine this off to length. So I've just touched off lightly with the tip just on the jaws here. And what I've also done is I've just touched off each jaw with the tip just to find out how parallel those jaws are, or square to the centre line of the bed of the lathe, and within 0.02, so it's at around about 7/10 of a thou. So yeah, I'm happy with that. So I've clocked up to this machine diameter here, which is the one we did all in one operation, and I've touched off here. We're going to come back exactly 50 millimeters, and that'll bring us off to length. Then we'll machine the OD here at 67 millimeters, and we'll bring this back to 10 millimeters in thickness. Once we've done that, then we'll set up for the bearing bores, or the bearing bore. That's quite nice. Right. A little bit more to do on that. We might bring that down a little bit closer to the 10mm thickness. Before I get too carried away, I'll just check that. I should have about 0.79 to come off. .85. Should leave us about 1/2 mil, and spot on. Right, I'll get this diameter down a little bit further. So I'm aiming for 67 on that. As I said, it's not a critical diameter, this one. So we've got 67.73. So 0.73 left to go. touch with some emery, and that's all done. Alright, I'll give it a zero that up and we'll start the bore for the second cup. Righto, so I've just touched off here. We're going to open this up to 47mm for the sizing for those bearing cups, and we've got to go 27mm deep. Yep, tons to go. Well, I'll keep roughing that out, and then we'll bring you back when we're going to do the final cuts. Right, we've got 0.03mm left to go, so we'll just dial 1015 in. I'll set it at that. Oh, well, hopefully we're there. So we're machining the seat down to depth at 27mm. Let's give it a scratch. Like that. Check that again, that's as if it's moved. It certainly moved. .97 of a mil to go, so I'm just going to take that out with a bit of emery. That'll do me, I think we'll be right for that. Alright, I'm just going to undercut in there by a couple of tenths just to give us a bit of clearance on that cup, so that I'm not pushing it all the way through or punching it all the way out. It has to be maintained. So I'll set up and do that now, give it a touch with a bit of emery, we'll deburr it, and then we'll get set up for doing the PCD holes in here, PCD holes in here, and I've also got to cut a slot for the motor support anchor, which has got to go in there as well. So I'll finish this off, bring you back when this is done. This is going to be a little bit tedious getting that final little bit. And then we're back to the mill. Alright. Righto, so we've got this finished off now. So it is just very light push fit into there. I won't take it all the way because it's going to get stuck like it did before. But for the last width of the cup, it's down to 0.02 interference, so it just makes it a bit easier for later on down the track. If it's ever got to be removed, you're not trying to punch it up the full length. Once you've got it clear, it's going to come out a little bit easier. Alright, so we've completed all the turning on this now, so we'll get it out of here and we'll get it set up ready for milling. Right, so as you're going through the machining operation, sometimes it's nice to sort of see your fitment starting to come together. You're starting to get a bit of an idea of how everything's starting to look. she's home. So that's the housing for our worm wheel that we're going to be popping in there. And we're going to do the drilling and tapping to match up with our drill and tap in our compensating ring here to position this. As I said, with that little blue that I made, I'll just have to make sure I get the orientation right compared to these, and also the slot we've got to pop in for the anchor arm for the motor adjust. So alright, so this is where the worm wheel is going to be sitting, up inside there. So that worm wheel is designed, I've designed these diameters so that the worm wheel will pass through. And as I mentioned back, I think it was back in the very first video, I like the idea of cartridge design where I can take an element, you can set all the backlash, all the preloads and shimming if required in a separate operation before you offer it up to the main assembly. It makes it so much easier for fitters, particularly if it's in very, very awkward spots, to access gear, to take it apart and work on it. If it's machined all as one item, which often you'll find the stuff is, and trying to set stuff in situ can be an absolute pain. So if you go for the cartridge design, which is what I love, it breaks it down and makes it so much easier for the fitment up. Alright, so we'll get set up and we'll get ready to do these holes. Right guys, we're going to go and get this set up ready for drilling and counterboring the PCD and the flange, and then we've got to do a drill and tap in this outer face here for the bearing retaining cover to go on, and it also has the seal. I was with a bunch of mates over the weekend, and they all tend to use the little light indicator edge finders, and I was telling them I use these little mechanical ones. And they were sort of under the impression that as soon as you start seeing this thing running true, that you're on edge, which isn't the case. You've got to wait till the thing actually kicks or actually flicks. So I thought I'd just quickly show, because other blokes might know about that, but I'll show you how these little things work. And these are great compared to using maybe an M mill where you're sort of touching up against the edge there, marking the end of it. I remember when I used to do this years ago, I used to use a bit of an old fag paper that you'd sit inside there, and you just wait until it got scratched off, and that was your 0 point. But these little edge finders are absolutely wonderful. But I'll show you how we set these. So hence the name of wobbler. You can see it's wobbling away there, and we just bring it on very, very slowly. And I watch the see it kicking off there. I'll just keep an eye on the dial at the digi readout. That's pretty concentric there. We just keep going until it kicks and moves, and we're on edge. And typically these things are within half a thou when they kick. So I've already touched off on the far side, zeroed it, come across. So in my particular case, I'll grab the camera and stand. Okay, this is going to be a bit rough, but I just go to my digi, and it's on the x-axis, so I just hit X and half. That's a bit of a ride, wasn't it? And once I've done that, I'll bring it across to 0. Bring it across to 0, and then we'll do the touch off on either side again, and split it in half. Bring it back to 0, and we should be pretty much concentric on that. And look, for doing PCDs, this is a good way to do it. It's nice and quick. You know, if you're out a few thou on a PCD, it's not going to matter. If it's critical, I'll set up with the little lever indicator and clock it. But for doing these sorts of things, just doing PCDs, this is nice, quick and easy. Alright, well I'll touch this off, get it into center, and we'll be back soon. Alright, we might just go through a couple of methodologies for drilling and counterboring for the little socket heater cap screws. And these are going to be for an M6 socket heater cap screws. I like to actually do the counterbore on these. They look a much more professional finish, I reckon, rather than having the head sitting up. So I like to counterbore them back in and have them flush. So that's an M6. So drilling through is fine. Because of the proximity to this diameter here, I can't really get in there with a center drill. So I'm just using one of these pointer tips, little carbide pointer tips. So I'll just mark the centers for the holes for that. Then we'll go through with our clearance drill. So I'm going to go through with a 6.2 mil, a little bit of clearance on the M6, and then we're going to counterbore that. And there's a couple of ways you can counterbore these blokes. I have these little counterboring tools. Good and bad. These I reckon counterbore a little bit oversized, and the heads look a little bit big in the holes. Some of them are okay. Some of them aren't so good. This is about 10.6. Normal size on an M6 socket heater cap screw is 10 mil, but this is slightly below that, which they typically tend to be. So sometimes if it's a really long stretch to get down, I've just got a series of flat bottom drills that I grind up. I've got a set of these that I grind up. So the idea being that you go in with a 10 mil diameter standard drill, and then come in with this afterwards just to clean up the bore, and it does these do a really nice job, particularly if you've got a fair bit of depth that you need to work to and you can't get standard boring tools. Throw it away. You can't get standard counterbore tools into place because they're too short and stumpy. So these are great for reaching down a little bit further. The way I'm going to do this one is I'm just going to use a 10mm slot drill just to come in, do the clearance hole, then come down and just open up the counterbore with this and just drop it down to depth. And once again, these work really well. This is a 10 mil, so it'll give me about 0.2 of a mil clearance on my measured diameter on this to set them into place. So that's how we're going to go about this. So we'll get started. I've already set up for the first hole. Oh, that was wonderful. We just took the tip off that. I just have to keep going very quiet, very carefully. I'll make sure I can still get some center holes with that. Alright, we got there. Now carbide's fantastic, but gosh, it's brittle stuff. Right, we'll go through their clearance drill. drill's got a horrible cutting action. I might just take that out and we'll go and give that, yeah, we'll go and give that a dress up. Right. Well, what I think I might do, rather than using the MLO as I was, I might go through and we'll use the standard drill bits with our flat bit, and we'll go around and finish these out. I'll get set up and do that first. Right, I've already drilled a couple around the back there, but all we're doing is going down 5.5mm deep as soon as the flanks of the cutting edge actually hit the hole. Alright, we'll start with the flat bottom one, and I'll bring you back when we get around this side. I'll show you how that looks. Alright, so we've got our flat bottom drill set up. I've already done the ones around the back. And just going to finish these ones off around the front and just show you how this flat bottom drill works. Righto, all done. So I'll set up now and we'll do the PCD on this, remembering I've got to be 30 degrees out to this one here. Alright, we'll get set up and I'll bring you back when we've sort of got wound away with that. Righto, so I've sort of drilled these all around. We've got them 30 degrees out of phase from these holes. On my detail drawing I had this listed as an M6, but it's actually an M5, so I had to go back to the model and just check that. So I have to sack the checker. Alright, I'll be out of work tomorrow. Right, I'm going to go down about 10mm on these ones. Right, Get these tapped out and ready. Now I need to cut a slot into here as well, primarily for that motor anchor to support the weight of the motor, but also allow it to pivot when we're adjusting it up and down. So the easiest way I think to get this orientation right will be to actually bolt this into the housing, and I'll set the housing up with this bolted into it at 90 degrees, and then we can mill our slots in and get ready for that. Alright, I'll set up and get ready for tapping. Righto, last hole to tap out. Tell you what, I'm loving these spiral taps at the absolute bee's knees. I might get some more of them. As I said, I got these from Bang Good, and I think it was John Mills from Double Boost who did a little bit of a show on them, a little demo, and yeah, I bought them straight away. At least I think it was John Mills anyway. Alright, done. Alright, I'll deburr all these, and we'll grab the camera and I'll give you a bit of a close-up of how it all looks. Righto, I'll grab the camera and I'll come a bit closer. Righto, so that's it, all the drilling finished. We still have to do the drilling and tapping for the BSP plug for the filler and the leveler on this, but we'll do that operation next. So that's our M6 socket header cap screws that fit in there quite nicely. There are M5s, as you can see we're 30 degrees rotated apart. Just for the setup on this, I've just used my 3-jaw chuck out of the lathe. I've just got it sitting up in parallel to get it up off the D14 pins, and just a couple of table clamps locks it down quite nicely. There's another jig I made up ages ago, just using a bit of laser cut scrap plate I got down at my scrappos. You can actually see where the lasers entered in and out, and it's just a 3-jaw chuck that I bolted on, and showing the face is nice and flat. And then I can actually bolt these directly down to the table. So this is great for small stuff, but yeah, couldn't quite make it with this bloke. I've just got a pole underneath there that I'm sitting on just to keep it nice and square. Alright, so we'll get set up for doing those plug holes next, and then we'll do an assembly and get ready for milling the slot for the motor anchor. Just before I pack it in for the day, I thought I might just set it up here and give you a bit of an idea of how this looks as far as size goes. So that's sitting on top of my saddle there at the moment. I've just got 3 socket header cap screws just holding that housing in place at the moment, but that's sort of the orientation that it's going to be in. And excuse my arm. The motor's going to be sitting, I'll just sit up there for the time being, but the motor's going to be sitting back here. So I'll just sit it on top at least, it'll give you, don't drop it, it'll give you a bit of an idea of the size. So, come back a little bit this way. So I'll just sit up there and I'll have it so it bolts down onto it. So it'll be a fairly compact little unit. So anyway, it's coming along, we're sort of getting there. A lot more to do yet though, but yeah, it'll get there in the end. Alrighty, I'll pack it in now and we'll be back soon.